Okay, as has been promised, this is the part 2 of your glycolysis, which will be uploaded by 9:30 today. Okay, and to start with, uh, just a wrap up, I have given you um, the basic or the overview of glycolysis and also the kind of transport system that the glucose are actually using. So just remember that the glycolysis reaction actually reaches to endpoint wherein they produced a certain metabolite, and it will actually produce 2 net ATPs after the 10 reactions. Okay, now the glucose, as I have been telling you, it will be by the end of the glycolysis, there will be a pyruvate that is being produced. And that pyruvate will be used on the next metabolism, which is the tricarboxylic acid cycle. Now, the ATP, of course, is produced and will be used by the cells. So, take note that there are two stages in glycolysis reaction. The first five stages are actually energy investment, okay? And the last five is energy generation phase, wherein on those last five there will be the production of two molecules of ATP and of course the end product, which is your pyruvate. Also in the first five stages, as I have mentioned, there is energy investment and phosphorylated form of the intermediates. These are synthesized at the expense of ATP. So, dalawang stage ha. Meron kang stage 5 at saka first 5 at saka last 5. Yung first 5, energy investment. Yung last 5, energy generation. Okay? Now, to start with, please may I refer you to this flash reaction. Okay, this is the summary of your glycolysis. Actually, this is the diagram of your glycolysis. Take note, as I have mentioned, that your glucose, whenever, regardless if this is being produced through catabolism or kunyari ininom nyo yan, meron naman pong glucose powder talaga, ano po, lalo na kapag ka OGTT, OGCT. OGTT, Oral Glucose Tolerance Test. OGCT, Oral Glucose Challenge Test. Those tests are actually to establish if the patient could be suffering from diabetes. Okay, so let's start with the glucose. Your glucose in this reaction will be converted to glucose 6-phosphate. And take note that the glucose 6-phosphate is actually the phosphorylation of glucose. So, alam natin kung bakit meron tayong phosphorylation, di ba? So, for a substrate to become active, para magamit siya, kailangan we have to phosphorylate that substrate. Now, this is happening in the cytosol. Okay? Everything is happening in the cytosol. And take note that the conversion of glucose to glucose 6-phosphate, ito po, glucose to glucose 6-phosphate, is actually by the help of your enzymes. And this enzyme is what we know as the hexokinase. The hexokinase has 4 isoenzymes. So that would be hexokinase 1, hexokinase 2, hexokinase 3, and hexokinase 4. Please note that your hexokinase catalyzes the phosphorylation of glucose to glucose 6-phosphate. Now, your hexokinase 1, 2, and 3 are found in the tissues. Okay? So, your hexokinase 1, 2, and 3 are found in the tissues. Now, your hexokinase, of course, this is an enzyme. It could be inhibited. So, an inhibited hexokinase may happen because of the presence or an increased production of your glucose 6-phosphate. Kapag meron ng accumulation, this could inhibit if there is an accumulation or an increase po nito increase. Ang mangyayari po nito, this will inhibit your hexokinase. Okay? So, take note that your hexokinase 1, 2, 3, again, hexokinase 1, 2, and 3, okay? Yan po, hindi pala nakikita, sorry naman. So, 1, 2, 3, they have a low Michaelis constant. If there is a low Michaelis constant, so ito daw ay low, Km, okay? Therefore, kung mababa ang Michaelis constant niya, it has an increased affinity for glucose or the substrate. That would mean our glucose nga. So, take note that your hexokinase, we are talking of hexokinase here ha. Hexokinase. So, if your hexokinase has a low Michaelis constant, then therefore it has a greater or higher affinity to the substrate, which is your glucose. And because of that, that will permit the efficient phosphorylation of the glucose. Also, ang sinasabi ko po ay 1, 2, 3, take note that your hexokinase 1, 2, 3 has a low maximal velocity. So, mababa din po ang kanyang Vmax. Ano po? So, when we say, if this has a low Vmax, this would not sequester cellular phosphate. Again, since your hexokinase has a low Vmax, this would not be able to sequester cellular phosphate. Now, so sabi ko, meron kang isoenzyme 1, 2, 3, and 4. Nasaan yung 4? Now, here comes the fourth. Yung fourth isoenzyme. Wait lang po ha. So, yung fourth enzyme or fourth hexokinase is hexokinase 4, which is known to be as the glucokinase. Inuulit ko po, yung hexokinase 4 is known as the glucokinase. So, where do you find this glucokinase? You can find this glucokinase in the liver and in the liver parenchyma and the pancreatic beta cells. So, if, for example, we are talking of glucokinase, always bear in mind that it may be named as glucokinase, but it is still a family of the hexokinase. And basically, glucokinase is a hexokinase 4. Okay? Now, if your hexokinase 1, 2, 3 is inhibited by the presence of glucose 6-phosphate, your glucokinase will be inhibited by the presence of the fructose 6-phosphate. So, kapag meron ka na fructose 6-phosphate, nag-signal na si fructose, marami na siya, titigil na si glucokinase mo. In the pancreatic beta cells, usually the function of your glucokinase is actually the glucose sensor. So, paano yung glucose sensor? It is the one that determines the threshold for the insulin release. So, siya yung magsasabi kung release ka pa ng insulin, oops, tama na, marami na masyado dito. So, you stop, or wala na masyadong glucose dito, you stop the production of the insulin. Yun yung sinasabi niya sa pancreas, ha. And also, this is responsible for the adrenergic response to hypoglycemia. So if the person is hypogly, then therefore your glucokinase is in the move. Take note that your glucokinase has a dual purpose. Both it participates in both situation, hyperglycemia and hypoglycemia. When you say hyperglycemia, you have an increase glucose in the blood, and when you say it is hypoglycemia, you have a decreased glucose in the blood. So actually your glucokinase plays it well. Okay, so depende kung ano ang sitwasyon mo sa katawan, sasabihin niya kung hyperglyc ka, marami kang glucose, o ka i-process natin yung mga glucose, yung mga sugars, and then we try to let the cell absorb it, okay, and continue to have the glycolysis proper so that we can use it properly and produce more energy. Pag naman hypogly, ang sasabihin niya sa liver, no, you have to perform your duty. Let's do the gluconeogenesis. Wala nang glucose to So, can we produce? Parang ganon. Glucose for the cells. Ganon siya ha. So, dual purpose po ang inyong glucokinase. The other difference of your glucokinase is actually, if your hexokinase 1, 2, 3 has a low Michaelis constant, this one has a high Michaelis constant. Pagka high ang Michaelis constant, therefore, it will need a higher glucose concentration. Okay, so this is a type of enzyme that needs a higher amount of the substrate or the reactant. Also, this has an increased Vmax or maximal velocity. Therefore, it dictates the liver to effectively remove flood of glucose in the blood. So, for example, na-detect niya na masyado na maraming glucose ang dugo nito, then therefore, your glucokinase has the capacity to remove whatever that is in excess. Actually, yung tinatawag nating MODY, that's M-O-D-Y, yung mature onset diabetes of the young, okay? Usually, kaya sila of the young nga sa mga bata ito, hindi ito yung mga common age na nagkakaroon ka ng diabetes, no? Usually kasi nasa 50s, minsan nagmamanifest, 40s, 50s, nagmamanifest yung diabetes. Pero yung MODY actually, maaga siya nagmamanifest. So, bata pa. So, there could be a problem in the glucokinase. Okay? Now, let's proceed. So, you have your glucose 6-phosphate here. It will be converted to, actually, the word is, this will be isomerized to fructose 6-phosphate. Again, your glucose 6-phosphate will be isomerized to become a fructose 6-phosphate. So, the isomerization is brought about or catalyzed by phosphoglucose isomerase. Okay? Take note that this reaction is reversible and is not rate limiting. Okay? Again, your glucose will be isomerized to become fructose 6-phosphate. And then your fructose 6-phosphate will become your fructose 1,6-bisphosphate. And this is actually a form of isomerization. Sorry naman po. This is a form of your phosphorylation. So, from here, glucose to G6P, ano to? Phosphorylation. G6 to fructose 6, this is isomerization. And fructose 6 to 1 to fructose 1,6, this is your phosphorylation. So, your phosphorylation, take note of the enzymes, ha? So, your phosphorylation is brought about by your phosphofructokinase 1. Okay? Phosphofructose kinase 1, and that is PFK1. So, take note that your PFK1 po, PFK1. That is your phosphofructose kinase 1, which phosphorylates fructose 6-phosphate to fructose 1,6-bisphosphate. This is controlled by the available concentration. Your PFK1 is controlled by the available concentration of your fructose 6-phosphate na po. Ano po? So, your PFK1, however, is inhibited by the increased level of ATP as well as an increased level of citrate. Okay? Inhibited. So, kasi po, when there is ATP, this will recognize, the PFK1 will recognize na, hindi na pala kailangan ng ATP kasi marami na. So, I have to be quiet. Okay? So, ATP, increased level of ATP and increased level of citrate could inhibit the performance of your PFK1. Now, what activates your PFK1 is, of course, the kabaligtaran. Kung ang increased ATP will inhibit PFK, therefore, a decrease in ATP, ibig sabihin, ang meron ka nun, increase AMP. Okay? So, if there is an increased AMP, it could activate the PFK1. Okay? Now, in some reactions, you would be, the glycolysis can produce F2,6-bisphosphate. The F2 is fructose 2,6-bisphosphate. Now, the presence of your F26, fructose 2,6-bisphosphate, this is just an additional note, okay, is a potent activator, okay? So, paano po na-form yung fructose 2,6-bisphosphate? When there is the presence of PFK2. So, dito, para maging 1,6, kailangan mo PFK1. Pero kapag ang nag-react dito po sa fructose 6 mo ay PFK2, ang mapoproduce niya ay fructose 2,6-bisphosphate. Hindi po yan. Ano po? So, that is actually the difference between PFK1 and PFK2. PFK2 can act as a kinase. Okay, again, PFK2 can act as a kinase. At the same time, it is a phosphatase. Okay? So, ito, kinase lang siya. Yung isa, phosphatase and kinase, yung PFK2. Okay? So, take note, in fed state, yung busog ka, there would be a decrease in glucose and an increase in insulin. Pag ganun ang case, again, decreased glucose, increased insulin, you have an increased fructose 2,6-bisphosphate. Therefore, glycolysis is enhanced. Kasi nga, marami kang glucose, okay? Now, in a fasting state, glucagon is increased. I stand to be corrected. In the fed state, hindi po pala glucose yung decrease. Glucagon is decreased, increase ang insulin. So, I am speaking of the effect of our hormones, ha? So, in the fed state, there is a decrease in glucagon, increase in insulin. You will produce a high amount of fructose 2,6-bisphosphate. Therefore, glycolysis is enhanced. So, mas mataas ang glycolysis niya. In fasting state, there is an increase of glucagon but decrease in insulin. Therefore, there is a decrease in the amount of fructose 2,6-bisphosphate. Therefore, there is no glycolysis but gluconeogenesis will start. Okay? So, dalawang kaso yun, ha? The fed and the fasting that affects your PFK2. Now, let's proceed with this diagram. So, you have your fructose 1,6-bisphosphate, which will be cleaved by an aldolase. Again, the enzyme is aldolase, which will cleave the fructose 1,6-phosphate and will produce glyceraldehyde 3-phosphate and dihydroxyacetone phosphate. Now, take note that your dihydroxyacetone phosphate is actually utilized in the triacylglycerol synthesis. Again, this one is utilized in the triacylglycerol synthesis. Now, dito po, sa glyceraldehyde 3-phosphate, this is where your glycolysis will continue. Pababa po siya. Ito na po, yung part na ito na po yung energy production po natin. Dito ay, ano yung first 5 stage? Ang sabi ay, energy investment, dito, energy investment, and dito, ito na po yung energy production phase. Okay, so you have your glyceride 3-phosphate that will continue to the glycolysis. This will be converted, okay, by your glyceraldehyde 3-phosphate will be converted to 1,3-bisphosphate. And this is done in the presence of your glyceraldehyde 3-phosphate dehydrogenase. Ulit. So, your conversion will be because of the presence of glyceraldehyde 3-phosphate dehydrogenase. This portion, ito po, this is actually the first oxidation reduction reaction. Okay, and take note that this one, your 1,3-bisphosphate, yan po, has a high energy, is a high energy phosphate. So, saan galing yung napakataas na energy nito? Because of the presence of the ATP, yun yung reaction, actually. Okay, the high energy phosphate, again, the bond, dito po, sa 1,3-bisphosphate, that is being produced has a high energy phosphate, and thus will drive, because of the high energy phosphate, that will drive the production of your ATP. Kaya may ATP po doon, when this is phosphorylated, kasi ito pong 1,3-bisphosphate, high energy po siya, tapos magko-convert siya sa 3-phosphoglycerate. So, this one is converted because of the presence of your phosphoglycerate kinase. And since this is a high energy phosphate, apart from the phosphorylation of this product, so meron kang 3-phosphoglycerate, magkakaroon ka na rin at this point, dito po, at this point, you will start to produce you will produce one, okay, molecule of your ATP. And then, your 3-phosphoglycerate will be converted to 2-phosphoglycerate. This is because of the phosphoglycerate mutase. So, ang tawag natin dyan ay phosphate shift. Okay? So, the phosphate shift, yung 3 magiging 2. Kaya yung 3-phosphoglycerate magiging 2-phosphoglycerate. Again, you call that as phosphate shift, which is due to the activity of your phosphoglycerate mutase. Okay? So, nandito na tayo sa 2-phosphoglycerate. Your 2-phosphoglycerate, there will be a dehydration of your enolase, thus producing your phosphoenol pyruvate. Take note that during the dehydration of enolase, there will be a redistribution of energy. Okay? When you dehydrate your 2-phosphoglycerate, there will be a redistribution of energy and the production of this phosphoenol pyruvate. Take note that this phosphoenol pyruvate is also a high energy phosphate. Okay? This is a high energy. So, basta ang keyword, high energy. High energy tong si 3-phosphoglycerate. So, at this point, diyan ka makakagawa ng ATP. Ito kasi actually, yung ano dyan yung high energy phosphate. Ito po, ito yung high energy phosphate, itong 1,3-bis phosphate. At dahil mataas ang energy niya, kaya niyang gumawa pa ng isang energy. Okay, na-conserve niya, gumawa na lang ng isang energy. So, kasama ni 3-phosphate, di meron ka na. Ito, high energy din siya. Okay, tapos, mas, mako-convert siya sa phosphoenol, which is has a high phosphate energy din also. Okay, so dito actually ito ang mataas dyan na high energy content, high energy phosphate. Yung dalawang yan ang high energy phosphate. So dito, dahil siya ang high energy phosphate, pagka na-process mo to, magpo-produce siya ng ATP. Along with ATP, of course, there will be production of your pyruvate. And the pyruvate is actually produced in the presence of your PK. And your PK is your pyruvate kinase. Take note that this reaction, dito sa phosphoenol to pyruvate and 1,3-bisphosphoglycerate to 3-phosphoglycerate, take note that this reaction is dependent on the substrate level. So, you call this two as the substrate level phosphorylation. Okay? So, ayan yung kabuuan ng glycolysis. It's almost 25 minutes. Now, I would want to just give you the idea as to what would be the alternate fate, okay, of your pyruvate. So, saan pa ba magagamit yung pyruvate? So, there are three. It can be used in the oxidative decarboxylation to acetyl-CoA. Pag naging acetyl-CoA na siya, tutuloy-tuloy na siya hanggang dun sa oxidative phosphorylation. Ito una muna, itong si pyruvate, pwede siyang mapunta sa oxidative decarboxylation to acetyl-CoA. Tapos, the rest is history. The acetyl-CoA will be used further in the succeeding metabolism. Or, it can also undergo carboxylation. The pyruvate can undergo carboxylation to ethanol. Carboxylation to oxaloacetate. Pyruvate, carboxylation to oxaloacetate. Okay? Which also being used in other metabolic pathway. So, yung acetyl-CoA, sabi ko nga, this is actually the fuel. Okay? So, di ba kanina, yung isang fate of your pyruvate, oxidative decarboxylation to acetyl-CoA. It has to happen kasi acetyl-CoA is the fuel to your tricarboxylic acid cycle. And of course, same with your carboxylation to oxaloacetate, which is used, of course, in other metabolic processes. And in bacteria, your pyruvate can be reduced to ethanol. So, kaya kung minsan nagkakaroon tayo ng fermentation. So, yun yun, So, yun yung three fates. Yung the last fate na sinabi ko for the pyruvate, of course, is present in the bacteria or microorganism. Okay, that's all, and thank you. If there are any questions, just keep on posting or asking in the stream. So I hope you are able to transcribe everything and you're able to do your activity, the glycolysis, properly. Okay, thank you and have a nice day ahead of you.